I suppose que you see que attached to the email that I sent to you with this link, I send the review package. I said, what is my goal? What is my goal? My goal is maybe I need to change the due date in Alex. But my goal is dedicate today. Well, today, no, I need to explain something first, and immediately I am start doing the review. And we are doing a review today and review Wednesday. Because therefore, my goal is set out the due date for the test 3 next week. What day? Bueno, is July 6th, because July 4th is a holiday. July 5th is Tuesday, and July 6th is the due date for the test number 3. Clear? Maybe I need to fix it in Alex, but I am doing, when I finish the class, I send the video, I fix it. So due date is July 6th. I suppose that we have time to do everything. I suppose. Okay, now we start the new topic. The new is the Cramer rule. Cramer rule, que is the rule that we are using to solve a linear system of equations using a new idea, que is determinant. Okay, let's see one example, and that's it. One example is, suppose you have the system like that: x 5x plus 9z equal 52. Equation 1, minus 6 x plus 3y minus 8z equal negative 42, equation 2, and 2x minus 6y equal negative 40, equation 2. 3 equation, 3 unknown. We study 2 different ways so far for solving. Now we use the new one, gets the last, I promise. Okay, using Cramer rule. Cramer rule is basically using determinant. So you set out one determinant. Okay, always is called a capital D. Capital D is determinant formed by the coefficients from the variable. Phi, 0, because y is missing in the first equation, 9. Negative 6, positive 3, negative 8, 2, negative 6, and 0. And we compute that. But not by hand, using the computer, using the software. But I want to explain the strategy. What is the algorithm? Now you compute another thing, it's called dx. What is dx? It's exactly the same, except that you replace the first column, that by the way is the column of the x. But this column, you replace by the right-hand side number, 52, negative 42, and negative 14. So es 52, negative 42, negative 14, and the rest stay the same. And of course, we compute this. But not now. Now I copy likewise dy and dc. So what is the organization? This is the same idea. You replace in the original determinant the column of the y by the right hand side. So now we have 5, negative 6, 2, 9, negative 8, 0, but you replace 52, the second column, no? Negative 42, and negative 40. Okay, and this is exactly the same. 5, negative 6, 2, 0, 3, negative 6, and the column of the 6 is the third one, 52, negative 42, and negative 40. Okay, and we compute this. This is too long, but it's not complicated. But no, I want to skip by hand because it's not the idea now. And now the grammar rules say that the value of the x, y, and z is equal to that formula. You divide dx divided by d. You divide dy divided by d. And you divide dz divided by d. And that's it. Okay? Okay, let's do it. But let's do it using GeoGebra. I want to show you. Let me try to share the screen, switching to GeoGebra. If this is waiting for me. Do you see right? GeoGebra? Cool. Because I want to explain in detail this. Look, I copy the, when I copy everything. I copy, for example, 5. Negative 6, positive 3, negative 8, uh-huh. 2, negative 6, 0. Okay, the coefficient of the C and the first one. Now I want to copy also, why not? Here, separate a little bit, to don't confuse me by myself. 52, negative 42, and negative 14. Well, so I take advantage, I have that. I copy. Copy. You paste here, paste. And you copy this part. Copy, and you paste here. You see? Beautiful, huh? Again, copy that. Copy. Separate a little bit. Paste. Copy this. And paste in the second column. Boom. Now finally is the z, the y, and to a paste 1, 2 here. Paste. Oh no, I did wrong. Copy. Paste. And you copy that. And paste here. Right click. Paste. Okay, ready. I have 3. 3, no, 4 determinant. The first one is this. I convert to the matrix. Bam, I have here. I change the name because I don't like this name. I copy capital D. Capital D. Beautiful. Okay, now I copy that. Create like a matrix. I change the name, rename. Is capital DX. So D. Cool. Now the Y. Okay, this is exactly the same. You mechanical. You're doing capital DY. Okay, and finally the Z. Create the matrix. Okay, is here matrix. And rename. I put rename DZ. Excellent. Now I go to the class, get the part in which you are doing the complicated mathematics operation. Yeah, I determine, you put determinant, Determinant. Determinant of what? Of the matrix. What matrix? The first one, okay, D, capital D. And the answer is 30. Okay. D is 30. Likewise, determinant now. Determinant who? Determinant dx. Answer is 150. Cool. Likewise, determinant dy. dy. 120. And finally, determinant easy. Easy. And the answer is 9. Wow. So I have almost. Only thing I need to do is division. I come back one more time to our board. Let me share the screen. Okay, here. So using the computer, using the software, the algebra, I determine the answer of this is 30. The answer of this is 150. The answer of this is 120. And the answer for this was 90. Do you see the whiteboard? Yes, okay. Entonces now hay division. 150 divided by 30 es obvio que es 5. Okay. Now, dy get 120 divided by 30 is 4. Why 4? And this is 90 divided by 30 is 3. C is 3. Therefore, the solution for this system is the triple order 5, 4, 3. Do you understand very well this or no? It's very, it's very, you know, some people like. Personally, I don't like too much. Okay, I prefer matrices, but you need to know every method because on the test I asked you, computed by the Cramer rule, you are doing another method, no credit. See, I say you, solving by Cramer rule, you need to apply Cramer rule. Okay? Okay, so si no question, let's continue. I want to explain now, this is the last part, I promise, the some property that you need to know, properties of a determinant. Okay, help me to manipulate a little bit property of determinant. And the first property say the value, this is important, guys, the value of a determinant change the sign, change signs if any two rows or column are interchangeable. As you swap two rows or two columns, what happened? Well, the determinant maybe with 40, now it's negative 40. The new one after the swap. Let me prove using example. It helped a little bit to understand the idea. Suppose this determinant 2, 3, 4, 5 is given. Well, you know how we compute this, multiplication this, and not change the sign, and multiplication this, and change the sign. This is 10 minus 12 is negative. Cool? Okay, but I want to do something. I want to, for example, interchange two rows. So a new determinant after this interchange two rows is 4, 5, 2, 3. What are you doing? Well, I am doing, this is a row 1, this is a row 2, look, row 1, row 2, row 1, row 2, but you swap, and you put the row 2 in the place of the row 1. Now this is my new row 1, and this is my new row 2. The only thing I did was swap. So row 1, interchange row 2. Let's compute the determinant. The determinant is 12 minus 10. Minus 10. 2. Wow. You see how change the sign? This answer is negative. And yes, it's an example, guys, but this is a fact. Always happen. And what about the column? This is the new thing that brings me determinant. Determinant is nice. Because in the matrix, no. In the matrix, we are talking about only row operation, row operation, row operation, row operation. In this case, no. In this case, we are doing row operation and column operation. And nothing, well, nothing, no. Something happened. Let's see another example. Suppose you interchange the column. Now you have 3, 5, 2, 4, no? I swap this. Column 1, column 2. This is the original column 1, and this is the original column 2. I swap, I put 2, 4 here, and 3, 5 in the first. Okay, it's interchange also, but column or row. I did row, now what happened with the column? Well, it's 12, and this is negative 10. Again, is positive. Clear the idea for the first property? Okay, when you interchange one row and one column, the value of the determinant is the same absolute value. The only thing it changes the sign. It's obvious. If you are doing two interchange, swap, or swap one and swap another, and to say is stay the same, positive, right? Okay. This is the property number 1. Important. The property number 2 is when you have, for example, if all the entry is equivalent to, say, elements. Any entry is the word you use in the books. In any row or column. Wow, noise. It's raining. What happened? I need to know what happened. Miss, I put a mute for you. Okay, Abulaham Derival. Do you think I sent email today, Miss? Answer me, yes or no? If all the entry and the determinant, no, hypothetically, row or column equal to 0, R equal to 0, R equal to 0. Okay. The value of the determinant, the value of a determinant is also 0. And this will sound logical, right? Suppose, to understand this. Suppose. Suppose that I have one determinant 2 by 2 that's easy to understand. 0, 2, 0, 3. You see, wow, the first column is 0, full 0. You say, actually, using the property, I don't need to do anything, it's 0. Because see, I'm doing 3 times 0 is 0, plus, and 2 times 0 is minus. The answer is 0. This is obvious. However, more complicated example, suppose this example 1, 2, 3, 0, 0, 0, 4, 5, 6. Suppose que you don't know very well, no? Pero you remember that property que say que when any row or any column is full 0, 0, 0, 0, 0, yeah, you don't need to do anything. You put the answer is 0 by property 2. This is a property 2. Okay? Somebody say something? No? Everything okay? Everyone follow me? I promise we practice this property in the review package. Property number 3. Actually, we have in total 5. Only 5. 5. Okay. If any two rows or column only in the determinant happen exactly the same row and column of the determinant. Have the same value, the determinant is also 0. Let me explain. Suppose 2, 3, 2, 3. In this case, we have one determinant 2 by 2, in which the row 1 and the row 2 is the same. When you compare this, it's 6 positive, and it's a 6 negative. 0. This is trivial. However, another more complicated example. No. For example, you have 1, 2, 3, 1, 2, 3, and you have totally arbitrary number, 20, 40, 60. You detected, wow. I remember I studied one property that when the one column or one row is the same, you don't need to do anything, the answer is 0. And not only equal, maybe they are also proportional, and the answer is 0. So not necessarily like that. Suppose, wow. Suppose that we have this determinant, look, and where you have 1, 2, 3, and here you have 2, 4, 6, and here I don't know another value that is not important. You detecting that this is not equal, no, but proportional, and the answer is also 0. So normally you have two equal row or columns. Likewise, this is the same idea. So you have, for example, I don't know, 5, 4, 3, 5, 4, 3, 20, 40, 30, two row equal, the answer is 0. And this is logical to understand this because we studied the property number 1. And the property number 1 says that when you interchange two row or two column, the value of the determinant is the same. Suppose proof like a contradiction. This idea. Suppose que no 0. Suppose que it's one value. Suppose que it's one value. 20. When you swap this and this, and they are twin brothers. But the answer should be -20. You see que es a contradiction? Because they are identical, entonces I suppose que es the same value, independent que you interchange. Okay, now what is the only number que when you, what is the number que es equal the positive value and negative value? It's the only possibility is 0, because 0 have no sign. So I have no sense to talking about positive 0 and negative 0. 0 is 0. Clear? Clear or no? Yeah, you follow me or no? It's Sergio. Is it clear? Okay. Number 4, another property. F5, I promise we start doing the review. In the review, you see example of this. Okay, so now the property number 4 say, if any row or column in plural of determinant, of course, is multiplied. Wow, multiply by a number. Suppose arbitrary value, k. The value of the determinant is also multiply or change by a factor k. Let me translate more clear language. Well, suppose example. Suppose you have again one determinant easy 2, 3, 4, 5. Okay, I did before and the answer was -2. No? And suppose I multiply one arbitrary factor equal to multiply who? The row 1. You say 2 times 2 is 4 and 3 times 2 is 6. And row 2 no, stay the same. No, nobody touch. The only 2 multiply this and this. And convert 4 and 6. When you are doing the multiplication, this is 20 positive, of course, and this is -24. And 20 positive minus 24 is -4, que es exactly the multiplication, this value times this factor. So not necessarily, it's different completely to the matrix. Because a matrix, when you multiply any matrix times one scalar, you multiply all the entry by this number. No. In determinant is enough, you multiply only one row or only one column. Let's do it with the column again. Column now. Suppose I create one new determinant is using factor 3, another number. And you multiply the column 1. Okay, to say 6 and 12. No? Where come from this? Well, 3 times 2 is 6, 3 times 4 is 12. And 3 and 5 stay the same. My multiplication 30 positive. And multiplication this is -36. 30 minus 36 is -6. -6. Okay, we get the same answer if you multiply the factor by the original value of the term. Do you understand clear now? We practice. Maybe we're using this property but backward. Not like a multiplication, not factorization. So you discover in one problem, okay, in one column, we have a common factor, we can factor out. You put outside the determinant. Because I know okay, it's equivalent to multiplication, so compute the determinant after multiplication by the factor. Okay, entonces the last operation, the last property, sorry, property 5 say property 5 say if you apply row operations, exactly the same we are doing in the matrix, but in determinant row operations, or column operation. This is the only difference between determinant. It's possible doing in column and row. The value of the determinant remain IMS unchanging. This is science fiction. Let me explain in detail. Suppose again the famous easy elementary determinant that we apply every day. The answer is -2, no? Now suppose que I am doing this row operation. Suppose. Remember the notation row operation, guys. Suppose 2 row 1 plus row 2 is torch and the capital row 2. Remember, I recall this part. The row operation consists of the one factor, get this number. This is the row or the column, no? In this case, column both, in which you multiply every element plus you adding the corresponding position in the row 2, and you get the new row 2. Okay, let's do it quickly, and you understand very well now. Suppose this is my new determinant after perform this operation. Then you get, it's obvious the row 1 stays the same. Participate in the game, however, it doesn't change. You change only row 2. And you multiply 2 times 2, is 4 plus 4 is 8. Okay, repetition again. You take, this is a row operation. You take, let me try 2 and 2. And you take the element in the row 1 is 2 and 3. No? 2 and 3. And you adding the corresponding in the row 2 is 3. No, is 4 and 5. No? This is row 2. This is row 1. So I did the first one, 2 times 2 is 4 plus 4 is 8. I did the first one. The second one, no. The second is 2 times 3 is 6 plus 5, 11. Okay, let's see what happened now. Compute this new determinant after the row operation. This is 22. Multiplication this guy, positive 22. Multiplication this guy is minus 24. And the answer is -2, exactly the same. This is unbelievable property. Okay, this is unbelievable property. And like what happened with the column? Yes, row operation or column operation. Suppose, hypothetically, another column operation, okay, it's 3 times C1 plus C2, torch and the C2. And we get the new determinant. Okay, let me explain the operation down here. Is you multiply by 3, we have 2 columns, no? 2, 3. And the column 1 is 2 and 4. And the column 2 is 3 and 5. And it stores this number in the column 2. Es, bueno, okay. The column 1 stays the same because participate in the operation. However, the final answer is storage in the column 2, no? Entonces we have 2 times 3 is 6 plus 3 is 9. And this is 12 plus 5, 17. And now you multiply here at 34 positive, and it's a negative 36. This is 34 minus 36, again it's negative. Unbelievable. It's amazing. It's really, really, really amazing. You see the application in the review package, guys. Okay? Now we start review package. Today and Wednesday. Review, review, review. When you are strong, you take the test. Okay? I promise that Wednesday I will send the test number 3 written, so on paper, right? And you have to do another Wednesday. You have one entire week to do your best, right? Okay, entonces review for the test number 3. We are doing question by question. You can interrupt me when you don't understand everything, anything. Review for the test number 3. Question 1 is a piece of cake. Question 1 is a piece of cake. Question 1 is, let's verify. No? You have the system, and for example, it's given the potential solution, and you need to verify if this solution works or doesn't work. So you don't need to solve it. This is one possibility, but it's a long way. No, you have 3 equations. I am copy, guys. I have in my hand the review package. Yeah, I try to copy here. Okay, cool. This is my system. 3 equations, 3 unknowns. And the solution that they propose me is x equal 3, y equal 2, c equal -1. Be careful with the signs. Yes, I try equation by equation, doing my best. I take the first equation. Equation 1, verify. X is 3, replace 3 here. Plus y is 2. Plus c is -1. Should be. Claim this statement, or it's obvious it's true, because 3 plus 2 is 5, and 5 minus 1 is 4. Okay. Equation 2. In order to be solution, must be okay in any equation. See, one equation failed, the solution doesn't work, and that's it. X is 3 minus 2 is y, plus 5 multiplication by -1 should be 12. 3 minus 2 is 1. 5 times -1 is -5. And 1 minus 5 is -4. And -4 is not equal to 0. This is completely false statement, and the answer is no solution. So not that the system have no solution. Maybe the system have solution, but I don't care. The important is this triple order 3, 2, -1 is no solution for this system. Okay? Do you understand or no? Okay, obviously it's the option B in the handout. No? Everyone follow me so far? Okay, understood. Emily T say understood. Okay. Okay, Emily T. You always understand everything very well. Okay. Now, let's move on to question 2. Question 2. Question 2 is super easy. Look, is x plus 4y plus 2c equal 3. This is my first equation. 5y plus 3c equal 4. My second equation. And the last equation is c equal -2. Wow, unbelievable. Easy, easy, easy. This is a typical, see you write like a matrix language, this is typical echelon. Echelon form because you see que in one equation, one variable is missing, in another equation, two variables missing. Typical echelon, ¿no? Entonces, when this echelon, we apply back substitution. No, actually, I know que Z is negative 2. Look at the last equation. Entonces, you apply back substitution in the second, ¿no? Entonces, you copy 5y plus 3z equals 4, okay? Pero I know que Z is negative 2, plugging in here. Entonces, 5y plus 3 times negative 2 is equal 4. So we have 5y minus 6, no? Because positive 3 times negative 2 equal 4. Now I move 6 to the other side. 4 plus 6 is 10 divided by 5. Wait. So I have in my hand C negative 2, y equal 2. Now finally I go to the last equation. Is x plus 4y plus 2z equal 3. I just copy the first equation. I replace x, no idea. Y is 2. And C is negative 2. Be careful with the sign. So we have 8 minus 4, no? 2 times 2 equal 3. This is x plus 4 equal 3. X is equal 3 minus 4 negative. So x is equal negative. Now final answer, my solution is the triple order negative 1, comma, positive 2, que es de y, no? This is x, this is y, this is z. Let me see. X is negative 1, y positive 2, and z is negative 2. Wow, fantastic. Is the option A in the handout. Of course, our test is no multiple choice. You need to show me in detail that work. Okay? You're detecting que es back substitution, no? The idea behind this. And that's it. Okay, let's do it. Okay. Number 3 question. No problem, guys. Do you understand or no? It's easy, eh? So far. Yes. Okay, cool. Now, number 3. It is existing again. Okay. Just copy that. But I see something weird in this system because suppose the last equation, in number 3, I see que 2, 2, 2, and 12. You can, if you want, divide by 2. You know, okay, when you divide, multiply any equation, this equation is the same. It's totally dependent. Entonces, x plus y plus z equals 6. This is my new equation. It is equivalent to the original. 100%. It's the same. In my opinion, it's easier when the coefficients are 1. But I see some contradiction. What contradiction? Look at the equation 1 and look at the equation 3. X plus y plus z is identical expression. Equal 10 or equal 6? Definitely. What is equal? Is 10 or is 6? Do you think it's contradiction? So when you see this, no solution. Pero suppose, bueno, professor, y si I don't see that? Okay, no problem. See, so I want to, suppose que I don't see. This is the beauty of the algorithm using computer. Okay, I don't care. I just copy the matrix, for example. Associate with the system, get 1, 1, 1, the vertical bar 10. This is the row 1, represent the equation 1. The row 2 is 1, negative 1, 3, 14. And the last one, 2, 2, 2, and 12. Okay, I go to the GeoGebra. I type in this. I apply, for example, reduce row echelon. To indicate me this in the test. You are doing it in that way. You copy the matrix. I understand that you put this arrow, you put this acronym RREF, is row. No, row, no, reduce a row, reduce it, reduce a row. The first R is reduce it, the second R is row, echelon is E4. And you transform it, but quickly, this matrix and another matrix, you see more clear the situation. Let's do it, let's do it, let's do it, let's do it. How? I go to GeoGebra. Go to the GeoGebra. Let me share the screen. Okay, we use it to apply Cramer rule. Okay, here, over there. Cool. Do you see GeoGebra? Yes or no? No, not yet. Wow. Okay, let me try it again. Oh yes, I select whiteboard. I am crazy. Now? Yes. Wow, fantastic. Now I select everything and the previous. I clear my house. New problem. I press in the keyboard deal. Boom. That's it. I copy my new matrix. 1, 1, 1. Ante. The second equation is the second row. 1, negative 1, 3, and 14. And the third row is 2, 2, and 12. I create the matrix. Remember, you select everything, go to create, select matrix. Automatically in the algebra part, you can see the matrix, and default they call N1, N2, N3, N4. You want to recall or rename, you change the name. But you copy here and cast. Reduce a row. Reduce it, row echelon of the matrix. What matrix? M1. Enter. That's the answer. Okay, let me try to interpretation this answer. Okay, immediately I go to the whiteboard. I copy that number and interpretation this. All right, doing. Let's do it. Yeah. Okay. The answer was 1, 0, 2. The vertical line the software don't give me, because this vertical line is the interpretation is like an equal part. Okay. Here. To separate the coefficients in front of the variable and the right hand side number, no? 0, 0, 1, -1, and 0. And 0, 0, 0, and 1. Entonces, see you see now, look at that, pay attention. So you see the last row, you see contradiction. Because when you translate this to the equation, remember this is the column of the x, this is the column of the y, this is the column of the z, this is the right hand side numbers. You see the 0x and this equation, another number, plus 0y plus 0z is equal. And 0 times any variable, you suppose hypothetically exists a 0 equal 1, this is contradiction. Therefore, the implication this is no solution. Now, when the system, you try your best, but it's impossible. And you select the option D, the technical name of this situation is inconsistent. When the system is inconsistent, it's because the system has no solution. Si the system is consistent, have at least one solution, maybe unique or infinity many solutions. Cool? Any problem? I am doing too fast or no? Too fast? Everything okay so far? So far, everyone get 100 points in the test. The question number 4. Cooper, Mr. Cooper, hello, how you doing? The question number 4 is super elementary. It's my gift in the test because you don't need to do anything. So when we are system of equation is given, and you don't need to solve it. No. The question says write the augmented matrix for the given system of equation. Only write the augmented matrix, and that's it. Of course, it's a weird, no, because we have a lot of variables. Number 1 and number 2, we have some variables missing, and you need to know that when you write a matrix form, when the one variable is missing, well, you put the 0 no, in the corresponding place. Plus c equal -2. This is equation 2. And the third equation is x minus y minus 10z equal -12. Equation 3. And the last is 12x minus 12y plus 2c equal 11. Entonces, don't try to solve it. No, this is not the equation. The equation is only write the matrix to be ready for the potential solution in the future. So remember, we have 3 equations. That means that our matrix contains 4, no? 1, 2, 3, 4. 4 equation. 4 equation. Our matrix contains 4 rows, 1 per each equation. This is the organization in matrix language, in matrix form. 3. And remember, in the column, we have 1 column for the x, 1 column for the y, 1 column for the z, 1 column for the w, that is our variable. The augmented matrix is separated by vertical line, the right hand side number. And that's it. So let's move in equation by equation. Equation number 1. This is 3. This is 9. This is -5. This is 1. And this is 5. Clear, right? The equation number 2. Equation number 2. X is missing. Y is 6. Z is 1. And W is also missing. And the right hand side number is negative. And the third equation is 1, -1, -10, -10. W is missing, no W in the third equation, and -12 is the number in the right hand side. And the last is 12, negative 12, 2, no W again, 11. Boom. Final answer. See, I asked you, for example, what is the dimension of this matrix? Oh, the dimension of this matrix is 4 by 5 because this matrix contains 4 rows and 5 columns. 1, 2, 3, 4, and 5. The classical column of the any variable plus one more extra, that is a reason it's called augmented matrix, right hand side. Done. No complication. Any question? There's some people that don't read very well the question in the test. So try to solve this. And spend time doing this. It is not my intention. Okay? No problema. Let's move on to the question 5. Okay, I'm doing very thank you, thank you, thank you, thank you. No problem. I know you are good. Okay, we try to do it. Okay, number 5. Question number 5 is a little bit complicated because we need to apply row operation by hand, not software. Unfortunately, the software don't allow row operation, but it's okay. Don't worry. Let's do it. Yeah, I want to see your work in detail. No, so it's given in the question 5. One matrix, original matrix is given 1, negative 3, negative 5, 2, 2, negative 5, 2, 5, 3, negative 5, 4, and 6. By the way, the dimension or order of this matrix is 3 by 4. 3 row, 4 column. Okay. And they want that you are doing 3 row operations. The first one is minus 2 R1 plus R2 storage in R2. Remember the notation, guys. The typical format for the row operation is we have factor. Arbitrary is given. We have the row that you multiply by the factor, the entire row 1. And you add in plus with another row, and this new number we store in the root. Okay, let's do it. Let's do it. Let's do it. Pay attention. Pay attention. Pay attention, and you have me say making mistake. Okay, look. One good idea, in my opinion, is copy, for example, copy negative 2 4 times. Why 4 times? Because we have 1, 2, 3, 4 elements in each row. I multiply by the entire row 1. This is row 1. Plus row 2. Equals something. You can do mentally or no. So what is row 1? Row 1 is 1, negative 3, negative 5, and 2. I copy that. Okay. And no, plus row 2. And who is row 2? Row 2 is this. Okay, so now I copy 2, negative 5, 2, and 5. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative positive 6, positive 6 minus 1, minus 5 is 1. Negative 2 times negative 5 is 10. 10 plus 2 is 12. And negative 2 times positive 2 is negative 4 plus 5. Entonces, what is the transformation, Professor? I don't understand anything. Well, the transformation is you transform this matrix in another matrix. The only row get changed is row 2. Therefore, row 1 stay the same, Row 3 stay the same. Nobody working with the row 3. And you copy that number here. 0, 1, 12, and 1. Cool. This is the row operation. Let me call this transformation 1. So actually, we need to do 3 transformations in this one. Do you like this organization or no? So people say, no, I don't like this. I am doing it mentally. I am good in the computation mentally. Okay, good, no problem. Let's do it now, the second transformation. The second transformation, transformation 2, column, is -3 as a factor, multiplication by row 1 again, plus row 3 now, and storage in the new row 2. Of course, we are doing this transformation of the new matrix, not in the original. This is the old. I don't work it anymore. It's a sequentially. Transformation 1 is this step. Transformation 2 is the second step. And so on, right? So I copy again, -3 4 times. Again, I copy any element in the row 1. Okay, was 1, -3, -5, and 2. I copy. This row, the horizontal, I copy vertical. I don't know because I see more clear. Adding the element in the row 3, que is 3, -5, 4, and 6. And you compute one by one. You compute this is 0 because -3 plus 3. This is a 9, positive 9, -5, 4. Okay, 0, 9, entonces dice 15, ¿no? -15, or positive 15, sorry, -9, -5, positive 15 plus 19, Uy. And this is 6, and negative, oh, it's 0. Okay. I respect this. So now my new matrix is, okay, new matrices, sorry, my new matrices. Wow, what the hell? New matrix is, let me erase that. Is, look, I copy, pero copy who? Copy everything in the row 1 and the row 2. Because the only row that changed is row 3. 1, -3, -5, 2, 0, 1, 12, and 1. Now, 0, 4, 19, 0. Cool? Finally, transformation 3. Transformation 3 is 5 times a factor of 5. Row 2 plus row 3 and stores this information in the new row 2. Again, participate in this transformation, row 2 and row 3, but the final answer is stored in the row 3. Okay, so I copy 555 4 times. Multiply by the corresponding element in the row 2. Who? This one. I forgot this. This is all. Okay, this is the new one right now. So I copy 0, 1, 12, and 1, right? 0, 1, 12, and 1. That one. This guy. Plus. I know okay, this is too long, and everyone make a mistake in this, but try to do, slow down, try to do your best, because I check it, no? So now it's a 0, this is 0, this is 0, this is 0, 0, 0. We navigate for this now. 4, 19, and 0. Okay, it's doing. This is 0. This is 9. This is 5 times 1 is 5 plus 4 is 9. And this is 60. 12 times 5 is 60. Plus 19 is 79. And finally is 5 times 1 is 5 plus 0 is 5. Okay. Now, this is the all now. And my last transformation tree is you copy everything. 1, -3, -5, 2. At least the row 1 doesn't change in this transformation, and 2 no. The only thing that changes row 3. And now it's 0, 9, 79, and 5. Boom. Final answer is the option D. And the handout. Sorry, I know it's too long. I know everyone make a mistake one, but if you are doing, slow down and take care. You have no problem. And this is important because in the review I have 3 examples of this. So I suppose it's important. I included this in the. Any question? Do you understand? You need to explain another part that you don't see very well. Do you understand very well the notation in the row operations? We have factors. Understood. So you have factor, it's a number, multiplication by the row. Okay, we consider a pivot. Remember, row something plus another row something x, row y, and the stores equal in the new row y, for example. There are coincidences in between 2, 2, 3, 3, 3, 3. Okay, this is a typical general equation for the row operation. Super. Let's practice another. This is equation 6, no? 6. Unfortunately, no. There are no software for doing this. It's by hand, only by hand. Okay, this is the matrix again. It's given at the beginning. 1, 2, -3, 4. -3, -5, +8, -10. 2, 0, -1, and 4. This the matrix is given at the beginning, and you need to perform all on this matrix, this transformation step by step. So sequentially, the first transformation 1, is 3 times row 1 plus row 2 storage in the row 2. Let me double check it in my paper. Oh yes, that's correct. Okay, so now I take 3 as a factor. 4 times, guys, in this case 4 because we have 4 elements in each row. Another more complicated matrix is not 4, it's maybe 20. And you multiply 1 by 1 by the element in the row 1. In this case is 1, 2, -3, and 4. Plus the 4 element and corresponding according to this transformation, the row 2 is -3, -5, 8, and -10. This is 0, it's obvious. +3 minus 3 is 0. 6 minus 5 is 1. -9 is -1. And this is 12. Is 12. Okay, so my new matrix after the transformation 1 is 1, 2, minus 3, 4, 0, 1, negative 1, 2, and row 3 stays the same. Okay. Next, I want to copy here semicolon transformation 2. Transformation 2 is minus 2 R1 plus R3 storage in R2. Okay, of course you forgot this. This is old. Now this is new. Sequential, step by step. So I copy negative 2 4 times. Multiplication by any element in the row 1 is exactly the same. Look, I copy, just copy paste, but the factor is different. 1, 2, minus 3, 4. This is identical to this. Plus the corresponding element in the row 3. Okay, in the row 3, and of course in this, row 3 doesn't change. So it's 2, 0, negative 1, and 4. I recommend you put enclose the parentheses. Because si one es positive, no problema, pero when it's negative, yes, be careful. Entonces 0, this is negative 4. This is 6, this is 5. 6 positive minus 1. And this is negative 8, negative 4, and negative 4. Okay. Now, after the transformation 2, we have the new matrix is 1, 2, minus 3, 4. 0, 1, negative 1, 2. And now you copy that. 0, negative 4, 5, and negative 4. And this is all. I finish with this. I never touch anymore. This is a new. Now. Okay. And the last transformation that the problem proposed me is semicolon transformation 3. It is 4, the factor now is 4, R2 plus R3 storage in R2. Okay, we try. Copy 4 times. Multiply by the corresponding element in the row 2. Row 2 of this. Is 0, 1, negative 1, and 2. Plus, 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 plus. The element in the row 3. Okay. The element in row 3 is 0, negative 4, 5, and negative 4. Okay, let's do it. Computation. S obligate 0, S obligate 0. This is 1, negative 4 plus 5. And this is 8 minus 44. Okay, so the last transformation 3 is 1, 2, minus 3, 4, 0, 1, negative 1, 2. I copy that last number, 0, 0, 1, 4. Wow. And this is my final answer because corresponding with the option. It's confusing, it's clear. I know it's too long. Yeah, I know. Okay, everyone making mistake. Pero no, so you're doing carefully. You have no problem, I suppose. Yeah, take care. Row operation by row operation. And this is my final answer. After the 3 transformation. Okay, one more, because it's important. I suppose it's important, row operation by hand in the test. Okay, one more, the question 7. Question 7 say, okay, one matrix given at the beginning Pero es too big matrix, es 1, 1, negative 1, 1, and 0, negative 5, 1, negative 2, and 0, 2, 0, negative 3, negative 4, 3, negative 5, 1, 0, 5, negative 1. What is the dimension of this matrix? I don't know. It's 4 by 5, no? 4 row, 5 column. 1, 2, 3, 4, 1, 2, 3, 4, and 5 column. I need to perform, fortunately, only 2 transformations. Transformation 1 and transformation 2. Transformation 1 is minus 3 as a factor, multiplication by any element in the row 1 plus the corresponding element in the row 3. Let me identification, right? Row 1, row 2, row 3, and row 4. So you multiply minus 3, in this case 5 times. Now let me see, 1, 2, 3, 4, 5, yeah. Multiply by any element in the row 1. This is the element in the row 1. Okay, so 1, 1, negative 1, 1, and 3, plus the element in the row 3. And the element in the row 3 is 2, 0, 2, 0, minus 3, minus 4, and 3. Equal. I forgot to say that this information you storage in row 3, new one. This is minus 3, plus 2 is 1, is negative 1. Sorry. This is minus 3 plus 0 is negative 2. Negative 1, negative 3. This is positive 3 and negative 3 is 0. This is negative 3 and negative 4 is negative 7. And this is negative 9. Minus 3 is negative 6, I guess so. Okay, so the new matrix after the transformation 1 is. Okay, the only row, guys, that change is row 3. So you copy exactly the same, except the row 3 is the only que change. I know that too much information is repeated. Sorry, but this is computer, no? And the computer working too fast. Please. I try to simulate computer now. And now it's negative 1, negative 3, 0, negative 7, and negative 6. Okay, this is my first. And we have one more, and that's it. No more. Transformation 2 is 5 R1 plus R4 storage in R4. Okay, but who is R1? Well, R1 is this. Who is R4? R4 is 2, 3, and 4. This one. We now combine somehow. Row 1, multiplication by 5, and row 4, adding, addition, and the new information I put in the row 4. So I copy the factor of 5. I copy 5 times 5. It's a 5, 5. Wow, it's amazing. 5, 5. Multiplication by the row 1 again. In this case, a coincidence because I don't touch the row 1 plus row 4, that is negative 5, plus positive 1 plus 0 plus 5 plus negative 4. It's obvious 0 here. It's obvious 6. Because 5 times 1 and 5 plus 1 is 6. It's obvious there's negative 5 here because negative 1 and positive 5 and negative 1 plus nothing is 5, negative 5. In this case 10, it's obvious 5 plus 5. And in this case 15, 15, 15 minus 4 is 11. No? 11. Okay, so my final answer doing the transformation to is I copy, copy, copy. Everything exactly the same except the row 4 can now is 0, 6, minus 5, 10, and the famous part is separate 11. Okay, the rest exactly the same. I use him, but I'll never change him. Cool. And this is my final answer. Okay, I select the option C. I don't know if it's good or not because I am not good in the selection. Let me try one more time. Selection. We are doing number 7. I seek a 6. I suppose it's okay. You follow me, guy? What's going on? Good. Okay. Thank you. Now, say okay, it's okay. Everything okay, professor? Okay. So for sure, guy, one question on the test is row operation. I promise that I don't put any complicated example. I put a regular example, no? Maybe 3 by 4 or something like that. Let's do one more question. Number 8 question. 8 question 8. A is a system. But I would like in this system we're doing number 8, number 9, number 10, number 11. We're solving using reducer row echelon. So the basic idea of the augmented matrix. And you put in the software, it's obvious because by hand it's possible, but you spend 2 weeks doing that. No. You spend 2 minutes doing that. Okay, so my system is minus 2x minus y minus 6c equal minus 77. By the way, there are no reason to too many negative. If you want, you change everything to positive because you multiply by -1. But it's okay. I don't care. I want to get the computer and the software doing this job. Equation 2 and my y plus z equal 70. Equation 3. The first thing that you should do is organization our linear system in matrix form using the augmented matrix. -2, -1, -6, separated by the vertical line, -77, -7, 0, because y is missing in the second equation, +3, -29. Wow, what the hell is that? What is that, guys? Okay. So putting off the microphone, okay? Now the last one, I don't care. The last one is 0, no, x is missing, look. This is the column for the x, this is the column for the y, this is the column for the z, and this is the right hand side number, right? Okay, 0, 0, 0, 0, 0, 0, 9, 1, and 70. Okay, cool. By the way, this matrix is, the dimension is 3 by 4. So now I want, in this moment, at home, and the problem is similar to this, can you see in the text? You put an arrow on the piece of paper, you go to the reduce row echelon form. Now I go to the GeoGebra software. Okay, you need to train it by yourself. Be familiar. It's super easy. I do it several times. I recording the video. You watching the video again so you have some doubt. And I try to. Okay, so you go to the GeoGebra. Let me share the screen. GeoGebra. Do you see that? Oh no. Yes. Let me select everything. You go to the spreadsheet and you delete. New computer. Home clear. And I want to put my new problem. New problem, computer clear. -2. -1. -6. -77. Okay. -7. 0. No y. 3. -29. Equation is no x 0, 9y, and 1c, and the right hand side is 72. This is my problem. Matrix 3 by 4, 3 row, 4 column. I create that one matrix. So you right click, you select right click, and the pop menu you select create, because there are different objects. In this case we are working with the matrix. Bam, and you see here in the algebra pop, and the name is M1. You put here in the class, reduce a row. When you don't finish the typing, you select the option matrix, no? And the matrix is called M1. And then boom, I copy now in my whiteboard the answer. 1008, 1007, and 01. It's obvious, guys. Well, let me show you. I want to copy this result. I come back to my piece of paper, okay, and your test, okay, and I copy that, okay, I am ready to analyze. Is 100, the line, the vertical 8, and 0107, and 0019. Okay, so this is typical format. When you see the identity matrix here, this is the name of this guy is identity matrix dimension 3, because it's 3 column, 3 row, square, and we have no extra block. No, it's identity matrix on the right hand side. It's obvious. It's obvious que x equal 8, y 7, and z is 9. Okay, so you want to make sure when in this moment you convert again. Remember, I convert system equation of the matrix, and using the computer here, the computer give me another equivalent matrix of the origin, and one more time I come back at the beginning, I write the equation. The equation is 1x plus 0y plus 0z is equal to 8. It's obvious that this is equivalent to say x equal 8. Likewise, I don't want to copy again. Y is 7 and z is 9. And the solution is unique solution, only one, at the point 8, 7, 9. End the story. Okay, the option A in our hand. Cool? Cool or no? Cool. Okay. We have time. Yeah, we have time to another interesting problem. Suppose now, number 9. Number 9. Okay. Can I erase the board or no? You're watching the video, no? Oh no. Yes, erase the board. Okay, no problem. Because you copy or no? You copy simultaneously with me, no? Okay. Some students say, no, professor, but I need to copy. You see, I don't copy, I don't understand. Okay, I understand this fact. Some people have the habit in person, in the regular lecture in person. You have the notebook, you have the teacher in front of you, explaining the whiteboard and the physical, no virtual whiteboard, using the marker. And you copy, no? To say this is the traditional way that you learn from high school, elementary school, okay? Okay, 16. Wow, we are number. Don't be scared with the we are number because the computer is doing by itself this job, not me, not you. Three equation, three or no, classical system of equation. I have no idea. Only I set up the matrix ready to put in the computer. A negative 7, 3, negative 122, minus 40, 35, minus 15, 16, 60, negative 14, 6, and negative 244. Okay, now in a few minutes I put in the computer, I apply again RREF, I obtain new matrix equivalent to this, but easy to understand, right? Let's do it. Okay, I switch into algebra. Okay, I suppose you see in that moment I clear the house, clear home, select D, I copy my new matrix, is 8, negative 7, 3, and negative 122. My second equation is minus 40, 35, negative 15, 600. Cool. Now 16. It's important you practice by yourself, no? No big deal, it's super easy. Other software is more complicated. I select this because I like this. I don't know. Symbol is possible use. I select my system. See, I make a mistake, copy one number, or change one sign, the answer is completely different. So be careful, double checking before start. Okay, now you copy here, reduce the row. It's a long form of the matrix A1. Enter. Boom. Surprise. Okay, what the hell? I don't understand anything. Well, I copy this number in my notebook. Wow, negative 7.8, 3 over 8, negative 61 over 4, and the rest is 0. What means that? What means that? I come back to my whiteboard. In my whiteboard, I copy this information that I obtained using the software. Do you see whiteboard or not? Do you see or not? Okay, cool. Now I copy. I copy 1, negative 7 over 8, 3 over 8. It doesn't matter, it's a fraction. It's not important. And negative 61 over 4. And the rest was 0. Okay. Therefore, listen to me. I need to understand this. When you see 0, that means the elimination process goes, elimination method, discover that this equation and this equation are completely dependent. So you can delete, you ignore that part. I make a sense, guys, because intentionally, when I did this problem, look. So you multiply, for example, by 2, the first equation, 2 times 8 is 16, 2 times 7 is negative 14, 2 times 3 is 6, and 2 times negative 122 is negative 244. If you likewise multiply by 5, the first equation by 5, but at the beginning I don't see that. Of course, I say that the computer help me to understand the system. Now I see that you multiply by 5, by negative 5, sorry, 8 times negative 5 is negative 40, negative 7 times negative 5 positive 35, and so on. It's obvious that you have two equations that are completely dependent. Okay, so what is the solution? Okay, the important is what is the solution? And well, we have infinity many solutions. And the typical format for the infinity many solution is, I try to find the identity matrix, okay, the dimension I don't know, and also I try to find another extra block that I call free variable, okay, here in the matrix, okay. Oh, no, exactly. Wait. This is this line. No, this line is here. Okay, and in the right hand side, well, we have the right hand side. Maybe red color. Right hand side. So this right hand side is that part. The identity matrix. Who is the identity matrix? Oh, I don't see any identity matrix because everything disappeared. Well, this identity matrix is this one. Okay, actually, is, remember, identity matrix dimension 1 is just 1. Identity matrix dimension 2 is 1106, and so on. Identity matrix dimension 3 is 111000, and so on. So actually, the block is the identity matrix is this one, and this is the free guys. The free guy, the free variable, the free guy is this and this. That means that the x variable is not free. The only free is y and z, two free. But how you write the final answer? It's easy. The final answer is the solution set is the point x, comma y, comma z in the 3-dimension space, because we have 3 variables, such that you express it, last equation, as a function, so x, 1x, is equal minus 61 over 4, plus 7 over 8, y, minus 3 over 8, z. So you move this guy and this guy to the other side in order to isolate the only variable that is not free. Is depending. Depending on what? Depending of y and z according to this relationship. This is a mathematical formula, no? To state the connection in between y, z, and x. And what about Y and Z? They are any real number. In other words, numbers. In other words, this is a free variable. And why not? Why is not free? Non-free. Because depending of Y and Z. Okay, too much. Too much. We are doing to the number 9 question. I promise the Wednesday I want to continue the review. We finish, I suppose. And the due date for this also Wednesday, I will send together with the link the test. You have one entire week, including weekend, long weekend, to do this test trick. Is a little bit complicated. Okay, cool. Are you agree or disagree? Okay. Remember, this is not democracy, guy. Okay, this is dictatorship. And by the way, I am the dictator, no? No, I'm a nice person. No? I want my student. Okay, of course, the student can want to pass, no? Okay, entonces, have a good day. Bye, everyone.